This is, to start out with, a pulse width modulation circuit set up to control an LED. I don't really have it making any decisions right now. It's just turning it on at 25% brightness, then 50, 75, and 100 in a loop. So let's see when it'll start that loop. Okay, there's 25, 50, 75, and 100. I'm only reading that out because I don't know how well the video capture is going right now. Tried to play around with the lighting to get that. But anyway, you can also see the voltmeter, the changing readings as it's going through. So I've got it staying for about a second and a half at those different levels. Now what that's doing, that's not actually changing the voltage, even though the voltmeter makes it appear so. It's actually reading the average voltage going through. The real voltage, the actual voltage being sent, well, through the resistor into the LED is 5 volts no matter what. It's either 5 or 0. The amount of time, however, that that 5 volts is sent through versus 0 volts is what changes the brightness. So if you were to slow this video down very, very, very slow, I doubt my camera is good enough to do that, but you would see a strobing LED. I mean, I'll play around with the camera, see if I can get that, but I really doubt it. I don't think this camera's good enough for that. But anyway, that's essentially how pulse width modulation works. And the advantage to that is you're not wasting as much energy to heat as you would if you were controlling it using different sets of resistors going through, let's say, different digital pins into the same LED, and then writing one is on at a certain level or off at a certain level to power that LED, because it's always a constant voltage. You're not wasting heat. You're using that same amount of voltage all the time when it's on. It's just turning off and on very, very fast. With my little brother here, we're going to try really hard to get this thing to vary the speed on it. You can still see the multimeter there. Alright, so we're just going to bend it a little bit. Alright, now let it just... Now try to get it to like slow down a little bit, but keep going. There we go. Another motor controlling circuit. This one's a little bit more complicated. It's got a transistor here, acts as a gate. So what it does, just a very brief explanation of that. There's a voltage being applied perpendicular to these two other gates here, and that, let's see, well, a transistor is essentially just a three-way diode. This particular one, I'd have to look at the diagram again, but I assume what it does, I believe I remember what it does, is when there's a voltage applied here, it allows current to flow through here. So very, very easy to use logic component. So now as this here is powering up, it's returning those values here that you see. It returns between 0 and 255, which is the motor's power settings. And of course the potentiometer reads 0 to 1023, so I had to divide the potentiometer's return value by about 4, so that the motor and the potentiometer can essentially just speak to each other. Turn that off, that's getting annoying even for me. So now what's going on then is that it allows a current to flow between these 2 points here. There and there. I don't know how well that's visible, probably not very. And then we've got this diode down here, which, I'll be honest, I don't entirely understand why that is necessary. I believe it has something to do with, let's see, not this, That's just the multimeter, the voltmeter. I believe it has to do with, yes, the motor. I'm using the same power source in here. I possibly don't have to, but this is ensuring that current can only flow in one direction. And I guess if the motor doesn't, I was about to say backdrive, that it doesn't reverse. It's going to backdrive anyway if it is put under a load. Anyway, that's a brief explanation of what's going on here. Now, and I will actually, I'm not just going to tell you, I'm going to prove if I can figure out where this is all going to go. There. And I don't know if I can fit this thing in there. Is it there? Yeah, there we go. So we do have voltage flowing between there and there. And you see that decreasing? It's because the potential difference here and here is lowering. That's no longer usable as a ground. So that is where it is getting its current from. And you can see as the current goes up, the voltage goes down. Alright. I think that's, no, that's the wrong one. Is it? No, that is. Okay. Alright. So anyway, that's basically just what's going on here. And as I said before, the advantage to this is that I can use my computer to basically just track what it's doing, where it's going, and if it's still functioning properly, as well as provide output based on that input. We're starting out with this time. It's got potentiometer here, push button here, and over here we're tracking those values. So turn it up, number on the right increases, turn it down, that's potentiometer by the way, the number decreases. I can push the push button and I get a 1, or I get a 0 if it's not depressed. And it's set up using, let's see, if-else statements to look for both a potentiometer value above 500 and the push button being depressed. It will not work if either one is not true. And sometimes it does jump if it is true. It's because we're not working with a whole lot of voltage here. Not enough to get it to start completely if it's not in the right place.